Let's take a look at the four sign combinations for factoring the integer coefficient quadratic trinomial x squared plus bx plus c as the product of linear factors x plus m and x plus n, where m and n are integers having the sum b and the product c. First, let's take a look at the plus-plus sign combination. Here we have x squared plus 10x plus 24, where m plus n is equal to 10, the x coefficient, and m times n is equal to 24, the constant coefficient. Since m and n multiply to a positive number, they must have the same sign, either both are positive or both are negative. Since they add to a positive number, they must therefore both be positive. So we can make a chart of positive integers that multiply to 24. First off, we have 1 times 24, but 1 plus 24 is not equal to 10, so those don't work. Next, we have 2 times 12, but 2 plus 12 is not equal to 10, so those don't work. Next, we have 3 times 8, but 3 plus 8 is not equal to 10, so those don't work. Next, we have 4 times 6 is equal to 24, and 4 plus 6 is equal to 10, so we can take m equals 4 and n equals 6, or the other way around. We could take m equals 6 and n equals 4. It doesn't matter, because in multiplication order doesn't matter. So we have the factorization of x squared plus 10x plus 24 as the product of linear factors x plus 4 and x plus 6. Next, we can take a look at the minus plus sign combination. Here we have x squared minus 10x plus 24, where m plus n is equal to minus 10, the x coefficient, and m times n is equal to 24, the constant coefficient. Since m and n multiply to a positive number, they must have the same sign, either both are positive or both are negative. Since they add to a negative number, they must therefore both be negative. So we can make a chart of negative integers multiplying to 24. First off, we have negative 1 times negative 24, but negative 1 plus negative 24 is not equal to negative 10, so these don't work. Next, we have negative 2 times negative 12, but negative 2 plus negative 12 is not equal to negative 10, so that doesn't work. Then we have negative 3 times negative 8, but negative 3 plus negative 8 is not equal to negative 10, so those don't work. But finally, we get negative 4 times negative 6 is equal to 24, and negative 4 plus negative 6 is equal to negative 10. So we can take m equals negative 4 and n equals negative 6, or the other way around, and we get the factorization of x squared minus 10x plus 24 as the product of linear factors x minus 4 and x minus 6. Next, we can take a look at the plus-minus sign combination. Here we have x squared plus 10x minus 24, where m plus n is equal to 10, the x coefficient, and m times n is equal to minus 24, the constant coefficient. Since m and n multiply to a negative number, they must have opposite signs, one of them positive, the other negative. Since they add to a positive number, the larger of them must be positive. By larger, we mean having greater absolute value. So we can make a chart of integers multiplying to negative 24 with the larger integer positive and the smaller integer negative. First off, we have negative 1 times 24, but negative 1 plus 24 is not equal to 10, so these don't work. But then we get negative 2 times 12 is negative 24, and negative 2 plus 12 is equal to 10. So we can take m equals negative 2 and n equals 12, or the other way around, and we get the factorization x squared plus 10x minus 24 as the product of linear factors x minus 2 and x plus 12. Finally, we can take a look at the minus sign combination. Here we have x squared minus 10x minus 24, where m plus n is equal to minus 10, and m times n is equal to minus 24, where minus 10 is the x coefficient and minus 24 is the constant coefficient. Since m and n multiply to a negative number, they must have opposite signs, one of them positive, the other negative. Since they add to a negative number, the larger of them must be negative. Again, larger as in having greater absolute value. So we can make a chart of integers multiplying to minus 24 with the larger integer being negative and the smaller integer being positive. First off, we have 1 times minus 24, but 1 plus minus 24 is not equal to minus 10, so this doesn't work. But then we get 2 times minus 12, and 2 plus minus 12 is equal to minus 10, so we can take m equals 2 and n equals minus 12, or the other way around, and we get the factorization of x squared minus 10x minus 24 as the product of linear factors x plus 2 and x minus 12. Now you may have noticed that the polynomial examples we use, the quadratic examples we use, have the same digits, just different signs. In general, if you take a quadratic that factors and change the signs around, the new quadratic won't generally factor. But these are special quadratics which just give us a nice set of examples. And there's actually infinitely many of these kinds of quadratics where you can change the signs around and still have a quadratic that factors. Another thing you may have noticed is that we always got our values of m and n that made the quadratic factor using the chart. Now, using the sign rules, you can always make a chart, but sometimes you might find there aren't values of m and n that work. So in that case, the quadratic trinomial does not factor. You simply run out of factors for c in the polynomial x squared plus bx plus c. So here's a summary of what we've learned about sign combinations. For the plus sign combination, m and n have the same sign. Both have to be positive. For the minus plus sign combination, m and n have the same sign, with both negative. For the plus minus sign combination, m and n have opposite signs. One of them is positive, the other is negative, and the larger of them is positive. Larger, again, as in having greater absolute value. Finally, for the minus sign combination, m and n have opposite signs, the larger of them being negative. So that's a brief overview of the 4 sign combinations for factoring the quadratic trinomial x squared plus bx plus c.